Hello everyone, myself Vinay Kumar. Today I'm going to talk about different bands in electromagnetic spectrum and how spectrum is suitable for image processing. Electromagnetic waves. Um, Electromagnetic spectrum ranges from the shorter wavelength, including gamma and X-rays, to longer wavelengths, including microwaves and broadcast radio waves. There are several regions of electromagnetic spectrum which are useful for remote sensing. For most purposes, the ultraviolet or UV portion of the spectrum has the shortest wavelengths, which are practical for remote sensing. This radiation is just beyond the violet portion of visible wavelength, hence its name. So, some Earth's surface material, primarily rocks and minerals, fluorescence, and emit visible light and illuminated by UV radiation. You can see that wavelength. It goes as short as 10 to the power of minus 12 and long as 10 to the power of 4. In the negative 12, 10 to the power of negative 12, we have gamma rays. The longer, as we go longer, as 10 to the power of 4, we have radio waves. Frequency is proportional to wavelength. Ultraviolet. You can see that ultraviolet comes in the 10 to the power of minus 6. It's in the negative. So its distance is 1 mu meters. Wavelength at meters. 10 to the power of negative 10 to 10 to the power of negative 5. We have the ultraviolets in this range. The light which our eyes or our remote sensors can detect is a part of the visible spectrum. It is important to recognize how small the visible portion is relative to the rest of the spectrum. There is a lot of radiation around us which is invincible to our eyes, but can be detected by other remote sensing instruments and used to our advantage. The visible wavelengths cover a range from approximately 0.4 to 0.7 mu meters. The longest visible wavelength is red and shortest is violet. Most common wavelengths of what we pursue as particular colors from the visible portion of the spectrum are listed below. It is important to note that this is the only portion of the spectrum we can associate with the concept of colors. Wavelength 0 to 0.4 to 0.446 millimeters. It's the violet color. You can see that visible 0.4 into 10 to the power of 6 and 0.7 into 10 to the power of minus 6. It's the range between where the colors are visible. Blue, it is around 0.4462 to 0.500. Green 0.500 to 0.578. Yellow 0.578 to 0.592. And orange has the range between 0.59 to 0.620, and red has range between 0.620 to 0.7. Blue, green, and red are the primary colors or wavelengths of the visible spectrum. They are defined as such because no single primary color can be created from other two, but all other colors can be formed by combining blue, green, and red in various proportions. Although we can see sunlight as a uniform or homogeneous color, it is actually composed of various wavelengths of radiation, and primarily the ultraviolet, visible, and infrared portions of the spectrum. The visible portion of this radiation can be shown in its component colors when sunlight is passed through a prism, which bends the light in a different amounts of according to the wavelength. The infrared region is in the range between 10 to the power of negative 7 to 10 to the power of negative 3. The next portion of the spectrum of interest is the infrared IR region, which covers the wavelength range from approximately 0.7 to 0.100, means 0.7 to 100 millimeters, more than 100 times as wide as the visible portion. The infrared region can divide into two categories based on the radiation properties: the reflected IR and the emitted or Thermal IR radiation is the reflected IR region is used for remote sensing purposes in ways very similar to radiation in visible portion. The reflected IR covers wavelength from approximately 0.7 mu to 3.0 meters. The thermal IR region is quite different than the visible and reflected IR portion. As this energy is essential, the radiation that is emitted from the Earth's surface in the form of heat. The thermal IR covers wavelengths from approximately 3.0 mu meters to 100 meters, 100 mu meters, sorry. Microwaves. You can see that the wavelength generated by microwaves is in the range between 10 to the power of 3 minus 3 to 10, 1. Sorry. The portion of the spectrum of more recent interest to remote sensing is the microwave region from about 1 millimeter to 1 meter. This covers the longest wavelengths used for remote sensing. The shorter wavelength has properties similar to the thermal infrared region, while the longer wavelength approaches the wavelength used for radio broadcasting. Because the special nature of this region and its importance to remote sensing in Canada, an entire chapter of the spectral image processing. Spectral image processing relies on using tailored mathematical algorithms in order to manipulate and enhance data captured through the spectral imaging process. Examples of simple manipulation include retouching, color correction, noise reduction, and changing image contrast. Processing techniques can also take a variety of complex forms. In the case of palimpsests, for instance, imaging scientists can create an algorithm to peel back the prominent over text, the uppermost layer of text, in order to reveal the undertext, the underlying text, which is often much more difficult, if not impossible, to read. Here you can see those texts. Shit. The processing of Livingstone's letter involved a high degree of collaboration between project director and the image scientist. After the letter was imaged, Vince Wisnik reviewed the images of each leaf and marked several regions of interest. He then submitted the marked up images to the imaging team alongside a set of questions to inform potential processing. The questions related to textual issues such as read-through and illegal handwriting, as well as physical qualities, water stains, wax residue, paper, paper scissors. Sorry. In response, the imaging scientist used several techniques to enhance the images of the letter, from applying the standard pseudo-color processing to the ranking images. To use a more complex multi-band method that sought to separate out the different text, chains, etc. The processed images included in this edition demonstrate some of the possibilities for enhancing text, topography, and other material features of Limestone's data, and for highlighting the relationships of these three elements. Alongside such processing, the team also evaluated the raw spectral images of the letter and provided a series of imaging recommendations to guide future work on Livingstone's manuscripts. Most of the processed images combine two raw spectral images together to create a pseudo-color image. Two images are locally adjusted in brightness and contrast over a sliding window, about 3 text lines high, to make the images uniform in appearance. The two images are then combined into one color image by putting one image in the red separation and the other image into green and blue separation. Where the two images are of comparable value, the pseudo-color image appears neutral, that is without color or black and white. Where the two images are different, the pseudo-color images appears red or cyan, depending on which image is brighter. Thank you.